Item information functions. Let's dive in. Yes, I know I keep saying dive in. It's because I'm really lame in terms of puns. Cause yeah, I'm a fish, so puns. An item information function. This is how IRT thinks about reliability. Because item reliability is replaced by item information. So each item information, each item response function can be transformed into an item information function. This tells us a lot. So it tells us the precision an item provides at all levels of the latent trait. This information is an index. It represents the item's ability to differentiate among individuals. Now, way back in the day, you may recall that we learned about a standard error of measurement. Well, it's back. Back again. But the standard error of measurement is the variance around the latent trait level. It's the reciprocal of information. So it can be more thought of as more information means less error. So the more informative your test is, the less uncertain your estimate is. Now, measurement error is expressed in the same metric as the latent trait level, so it can be used to build confidence intervals around our estimate. Our item information function has a couple of pieces. It includes the difficulty parameter, and that's the location of the highest information point. I have a figure coming up to illustrate this. Now, discrimination is the height of the information. So large discriminations mean that you have tall and narrow IFFs. And these mean you have high precision in your estimate and narrow ranges around your estimate. So you have really nice and tight confidence intervals. Low discrimination means you have very short and wide item information functions. And a consequence of this is you have low precision of your estimate and a broad range of where someone's true score is. So here, I've illustrated this. Have I illustrated this? This figure looks identical. Oh, I see what I'm doing. Okay, so here I'm displaying the item information, which gives us the relationship between trait level and probability for those three models. Now, I'm going to flip that to show you what the information curves look like for those exact same estimates. So in the 3PL model, we have this item has really a ton of good information for individuals around trait level, with the trait level 0. The further away in either direction that they go, the less useful it is, because it can tell you that someone is, between -1 and 1, but if they get it correct, it can't tell you any information above and beyond that. It can just tell you, oh, they're better than 1, or they're worse than -1, versus these other two, this 2PL, which gives kind of more broad information at the low end and doesn't tell us a lot about at the high end, versus our 4PL model. Now, I realize that you may think that given these three items, that all 2PL, 3PL, and 4PL have this kind of information set up with high precision. No. These are just 3 examples of items. They happen to use different models to kind of illustrate what these curves kind of look like. Okay. Another fun fact, these item information functions are also additive. This allows us to judge the test as a whole and to see at which part of the range the trait is working the best. So when we add up those three items, you'll notice here that they effectively overlap. They give us the same shape. So if we were to look back, we can like see that you get the shape is preserved. So the total test with these three questions gives us a ton of information at the middle of the range, some decent information at the higher range, and not a ton of information at the low range. So this test is helpful at will give us the best, tightest estimates in the middle. But the higher and further away you go, the less confident we are in those estimates. So here I've kind of imposed our two figures along with the standard error. So here we can see that our standard error in the solid, in the dotted line, is widest where we have the least amount of information. And we have the smallest standard error where we have the most information. So I'll see you later. Bye!